Hello. The question statement is a person measures the depth of a well by measuring the time interval between the dropping a stone and receiving the sound of impact with the bottom of the well. That means we are dropping a stone here, okay, and then when it strikes the surface of the water, we are receiving the sound and we measure this time. By measuring this time, we measure the depth of the well. Okay, so what is the time? The time is the dropping time of the stone and the reception of sound that originated from the surface of the water. Okay, so this is the total time. By measuring this time, we measure the depth of the well. That is what is said in the first sentence. The error in the measurement of time is delta t. So when we measure this time, we get an error of 0.01 second. And length, we found out that the length is 20 meters. Okay, that's fine. Take the acceleration due to gravity as g equals 10 meter per second square and the velocity of the sound as 300 meter per second. Then the fractional error in the delta L over L is closest to how many percent? Okay, so this is what we have to test. Now simply what we have to do is from this question we are clear that we have to establish a relation between time and length or the depth of the well, and from this when we calculate the error we are going to get the differential or the fractional error in the length. Okay then, but how do we measure that? So it's quite simple actually. Now what we can do is we can measure T1 and T2 separately. Okay, let's do that first. Okay, so T1 is the time of dropping of the stone. Now for dropping, the initial velocity is 0. Okay, and if initial velocity is 0, the acceleration is acceleration due to gravity and this depth is L. Okay, so we can use equation of motion equals to L equals ut plus half at square or half gt square rather. And by writing this equation we are assuming that the downward direction is positive, so we have taken L and G as positive and upward direction will be treated as negative. Okay, but there is no quantity in the upward direction. Okay, now the value of u is 0, so this whole term, the first term in the right hand side will become 0. That means the L will be equals to half gt square. Okay, and this t is actually equals to t1. So from here you can get T1 as 2L over G under root. Okay, so this is our equation 1 and this is equation 2. Now we have to get the value of T2, this T2. Okay, so what is T2? T2 is the time taken by the sound that originated after the impact to reach the surface. Okay, assuming we are hearing from here from the level of the well. Now there won't be any acceleration for the speed of velocity. Okay, that means we can simply use the formula speed equals distance over time. So here the speed is speed of sound equals distance means L over time is t2. That means t2 equals L over v, which is equation 3. Okay, now we can just simply put the value of 2 and 3 in equation 1. Okay, so in that case, T will be equals to T1, which is under root 2L over G plus L over V. This is T2. Okay, so this is the equation. Now this is the relation between T and L. Now if we get, if from this equation we are going to get the error, the differential error in the length. But how do we get that? We can differentiate this equation directly. Okay, so we can directly differentiate this equation. So we are not given the time, so we won't be differentiating it with respect to time. Okay, so suppose this is del t. Okay, now this can be written as under root 2 over g times under root L, and the differentiation of under root L will be power in the front, and there will be reduction of 1 in the power. That means L raised to the power half. Now we are going to differentiate L here. Plus, again, the velocity of the sound is constant. That means here you will be getting delta L. Okay. Now from this equation, we can just simplify this equation, and we are going to get 1 over 2GL and delta L plus 1 upon V delta L, which means we can take delta L common here. This is delta T. Okay, but what do we want here? We want the value of delta L over L. So we are going to divide both sides by L. Okay, let's do one thing. Let's write down this with a different color so that we can remember that we have divided the equation by L. Now you have to just put the values and you will get the answer. So delta T is 0.01. Okay, this is 20 equals, and this will be 1 over under root 2 into 10 into 20 plus 1 over 300, and this is the delta L over L. Sorry. So from this, this will be 0.01 divided by 20 equals, now this will be 1 by 20 plus 1 over 300 delta L over L. Okay, so we can just take this side, we can cross multiply, and then we will be getting delta L over L as 0.01 divided by 20. Okay, and this will be in the denominator again. Okay, now what we can do is we can multiply 20 in both the terms in the denominator, and then we are going to get 0.01 divided by 1 plus 20 over 300 means 1 by 15. So this will be 16 over 15, which means 0.01 15 over 16. Okay, now another thing, you're given the answers in the percentages. That means you have to find out the fractional error in the percentage. And if you want to find out the answer in the percentage, then what you have to do? Okay, so what we can do here, we can just simply multiply both sides by 100, and by doing so we will be getting the answer in the percentage. Okay, so this 100 times 0.01 will be giving you 1, and that means 15 by 16%, which is nearly 1% or a little less than 1%. So definitely B and C cannot be the answer. Okay, these are the wrong options, and also D is very less, 0.2. So again, this can be answer. So approximately, okay. And in the question also you can see that it is asking for the closest value. Closest value here is 1, A option. Okay, so our final answer will be option A. Thank you.